Alright guys, we're back live again. I had to take a nap and just chill a little bit. I would admit that I've actually been playing around a little bit and maybe feeling a little bit tired again. It's so dark and um, gloomy today. That's not making it better, but we'll get on anyway because there's no stopping us. So let's get to it. Let's get back to work. I'm excited to be back here to do what I love to do best. Let's go. 1 second, I'm just trying to make sure that we're up live and running. Yep, looks like it. And so where did I stop? I guess I was going through the modules one by one to just see places to first make sure like things are working as they should and look at places where we can make some API improvement. I guess I'm just gonna start all over from the first maybe save parser and just I should have actually restarted these, but it is what it is. It's okay. Um, so relations, save that. Let's just close everything and let's start all the way from attribute relate. Um, this looks good. So this way we can for a connection we can get all the metadata we need, like the connection struct and also the connection itself, the connection string. So things like a student writes book or something like that. So we get the edge and we also get the destination node string. So currently I have this implementation, and previously I was actually making the specification of, I believe, the connection string or the model, either of the two, optional, but I've actually changed that. So now if you're specifying a connection, you would have to specify the connection name, the type, the struct itself. So for example, if student writes book is your connection struct, you're gonna have to specify that, and also the string. So the string is like writes book, right? So the current struct would be students, then writes book. And let's go to permission. So one thing we did in permission is previously we had a function called get token, but rather than doing that, it's more idiomatic in my opinion to just implement two tokens for permission. So that way we can just like use it directly without having to invoke an extra function which introduces an extra layer of indirection. One thing I'm looking to consider is actually remove the need for having, so currently most of the attributes support like two like or at alternative. So for example, let me show you what I mean. I could probably show you in a more practical way. So you could specify, let's say, assertion as or permission. Let's use permission. Or you could do, so you could have your permission, you could say none, or you could use permission function fn. So basically what that does is, let's say you've got a function, let's bring this up, and the function is allow user. That's the name of the function, right? That's the permission. If you're gonna pass it to this, you're gonna invoke that function. You're gonna say allow user. Let's say this here just does a print allow user. That's all it does, right? And it expects an expression, so we should probably return. We could return nothing, but let's return boolean. So let's say we're just doing I don't know, true, right? So we're gonna do this. If you want to use the function alternative, you pass the path. So in this case you pass the function identifier, right? These two are equivalent. However, this first one is actually much more flexible, and let me show you what I mean. So you can actually inline the expression here and just do something like this, right? So with this you could invoke the function and do this, allow user, invoke it, whereas you couldn't do that with this. You couldn't inline an expression because it's a path. You would have to define the function externally. So I'm currently supporting these two approaches, but you cannot specify the two concurrently. Then it's gonna throw a compiler error, so you don't have to worry about misusing the API. But this is just a matter of like preference, and I'm looking to like, should I just support one approach? If I'm gonna support one approach, I'm leaning more towards taking an expression, because an expression gives you more flexibility. You can think about like, we could have something like user type, um, user user type. Let's say we've got this. We could take that off, or it doesn't matter. So let's say this takes user type, right? And you do something like that, and just say we return the user type, of if it's valid. The benefit of doing the first approach is, with this now we could just do something like, say user type user, or we could actually just take this whole expression and do, true dum 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 dum. We could do something like this. Whereas if we would do this with this, we would have to create an intermediate function. So something like, allow admin, and here we would do allow admin, right? That could be a good thing. It could be like, but anyway, currently we're supporting both approaches. I was looking to maybe to minimize the mental burden to support only either rather than both. But if we're gonna support both, I'll probably support just having an expression. And the second change which I forgot to mention is, I probably should, I apologize for that. I'm gonna just take the opportunity to update some of my packs. Interesting. It's quite a lot of stuff. Astro. Okay. That's quite a lot of update. Okay, that's fine. Let's go back to. Actually, I'm just gonna go back here. So, if we go back to the permission, one other change I'm making is, previously we would have to specify. We're taking like a literal string. So just like I did show you now, like if you have permission, then you take in, you could take in like a function called allow user, right? We took a literal string, but now I just want to take an expression directly, so hopefully we wouldn't have to specify the codes. So let's disable inlay int. Yeah, that's fine. It looks good to me with the permission. Let's go to the field casing. So currently this just handles, well, the casing of the field, and the whole idea is that if you really think about it, when you're working with this, you're only interested in the serialized state of the field, the field name. So imagine you have a user struct, and you've got multiple fields on the struct, username, first name, age, and all that, right? When you're using something like Serde, which is like a standard in Rust, sometimes you might want it to be serialized in snake case, camel case, there's kebab, there's Pascal, but typically people use, camel case and snake case, right? So the whole idea is that if there is no explicit definition, right, we just use the struct name as is, as you've written it. That would be the default. So if you have like a first name, let's say you've defined a struct called user, and you've got like a first name, blah blah blah, right? Let's say you've done something crazy like this, you're intermixing them, right? We're gonna take, in the serialized format, we're gonna take, let's say we've got a date, let's say we've got this, we've got user, we've got this data called like first name, right? We will take this serialized state as this. So the field names would be first name, a last name, and age. This would be the field, right? By default. However, if you use Serde and you do something like, Serde serialize, usually use deserialize also. If you would do something like this and you would say Saturday rename all to camel case, by default, without doing that, um, this is default without explicit field casing. But with this new one, now you're gonna get something a little bit different. First, we would focus on the struct level casing. That is like the the the, the default now. Using struct level casing, right? Now you're gonna get something like this. Everything is gonna be in camel case, right? You can also have like Pascal, kebab, and snake case, and the field name would be well this now, right? However, you also have like an alternative. Look at a scenario whereby you could, even though you specify that, you could say this should be nickname something, right? In that case, where you have like field override, right? You're gonna get something like this, and the field name would be first name, nickname, and age, right? So if we follow that heuristic, you would see that we're able to determine a lot of stuff at compile time, and that is the whole idea. So when we're talking about field ident uncased, we're talking about the default when you've not specified anything, and field ident cased is when you've specified the casing. With the default using the struct casing, and with field casing overriding that, or field name. So we have this focusing on that, and so by default you have the uncased, and the casing can be transformed to whatever case is specified basically. So you can transform this from uncased to cased, and yep. So basically, when we are instantiating this, when we're initializing on case, we pass in the on case field name, the default, um, as it's written. Then we pass in the casing, and based on that, we're able to like transform it to the case format. And this looks good. We've done everything we need to do here. I need to remove the example here. I could probably just discard that. About this, looks. I did a rename. That's fine. That is what changed here? Oh, I renamed that. That's fine. That is also fine. Person, that's fine. So now we could go to the generics. Generics module is where we handle all the implementation detail related to the generics. So now I'm implementing get field generics meta, and this is a little bit tricky. This part is actually going to be quite tricky, especially when you're dealing with edges. So um, get so we go like get fields generics meta, and I'm actually thinking usually for every kind of field, we go to this part. From here we might actually need 3 generics. So by default here we're just gonna need one kind of generics, the generics used on the field name itself, right? So let's say we've got, I could actually just copy one of the examples from this other place. Is we could use this. So let's say we've got something like this, hypothetically. When you're dealing with other kind of field like string, and let's say this got like generics, we've got lifetime generics, blah blah. We've got B, Brett, Hagen,
Do I have a CS degree? No, I don't. I am mostly, I mean, self-taught. The idea of self-taught doesn't really make much sense. Because no one teaches themselves. But I get what it means from that perspective that you didn't do that the formal way. But yeah, I took the informal route. I just read a bunch of books and did a bunch of practices. Yeah, but no CS degree. Why? Why did you ask? So you could also have a lifetime restriction to you. Let's say we're doing something like this. You just go crazy. Oh, I appreciate that. I appreciate it. It means a lot to me. Maybe I should get a CS degree now. I guess I'm just going through the school of life. How are you doing today? And thanks for joining the stream. Where are you chatting from? It's nice to meet you. So yeah, we've got like this. You could have like something crazy, and you can just go crazy, right? So let's imagine we've got a field called Monica, and that actually takes T, or like it could even be something crazy like some stuff, blah blah blah, takes TU, and well, we're taking a reference to that. Da, da, da. No, and yeah, we're taking B. We're just going crazy, right? Actually, reference to B. So imagine this kind of scenario. We need some stuff from this. Oh, thank you. That's such a big compliment for me. Thank you. That means a lot to me. I appreciate that. Because you seem very talented and intelligent the way you talk about the problem, wondered about your education. Programming generally goes well with CS. Yeah, that is true. I guess I'm just yeah, that's a big compliment. But I think I'm just generally I've always been very curious and inquisitive about things generally, like not just programming. And I grew up liking math and physics, calculus and stuff. So it was just natural for me to I enjoy this stuff generally. So I feel like even school, like doing a conventional CS degree, might even kill a little bit of that passion. But I just enjoy learning generally, and I also enjoy teaching. I'm maybe not the best at it now, but I'm trying to get better. But that means a lot to me. I really appreciate that. Thank you so much. Yeah, and I also spend a lot of time doing this. So generally now we need a bunch of metadata from this because I probably need to give you guys a background on what I've been working on. Um, but we the next part I need to get information about the generics because so what even got us here was that everything was working. We was like ready for alpha release, right? However, we didn't have support for generics, lifetime generics and normal generics and all that. And I felt like I mean we can get away with that because when you're defining the models, you can get away with just not having generics. Um, but that would be a huge limitation. I was thinking, especially when you're supporting other libraries, you're trying to if you're considering integrating a sync GraphQL, for example. If I remember the implementation detail correctly, if you're using an interface in a sync GraphQL, it typically uses generics quite a bit because like you the way it's implemented is such that you define a generic for the base struct and you can use that for like multiple implementation. So I was just thinking like it could be for any other stuff. You want to reuse your struct for other stuff, right? Then it does make sense for us to support generics, right? Because there's lifetime generics. If you're gonna have like references for any of your field, then you need to use lifetime generics itself, and that was what like brought us here. So you can imagine a kind of situation where a field does have a generic or uses generic here. Let's say we're even using generic here. We are concerned about this, right? So we want to get, we need this information. Let's say this field type metadata, and the first one we need the field generics. Let's just list them. The first thing we're gonna need the raw field type generics. I'm really terrible with naming. raw, raw field type itself, and that comes with the identifier of the type, right? And it also comes with potentially the lifetime and also generics, right? And this could be like the normal basic um, type, but you could also have. I'm also going to support for like tuple and array, especially tuple, because you could have array, const array, and stuff like that. If you could have something like t, and you could also have something like t, something like n or whatever. But now we're focusing on. I think it's more important for us to like focus on these other ones, because anyway, when you're dealing with your database, technically you could have something like this for like if you have like predefined set of like fixed array rather, right? But I would actually recommend that if you're gonna do this, it's better you use the concept of nested object. By digress. So we have the raw field type, and we mostly just need these three things. I'll take this out in the meantime. We need the ident, the lifetime, the generics. Technically speaking, lifetime is also generics. However, when you're dealing with like something like link many, look at it. This kind of scenario, you're linking to a foreign class. In this kind of scenario, we actually are interested in the link type. So currently, I'm using a literal string, but I'm actually looking to support the type here. So imagine this also uses like generics, and you've got something like this. And I'm gonna tell you why I am making it compulsory for you to like specify um, the link type, the link attribute, link many attribute. The reason is that think about, technically when we're doing our macro, we can parse this type and just take what's within this angle bracket and discard the link many. Then we would have to enforce the user, like we would have to tell the user you need to use the link many stuff we've provided. But how about a scenario whereby a user actually does an aliasing, right? So you have something like linked user, right? Bam. Um, Actually, let's do link many. Nah, link many. In this kind of scenario, the user comes here and does dun dun da da dum. Suddenly, we are not able to parse that from the AST. Like we are not able to get the user struct itself, right? Because now it has been aliased. Technically, we can probably get a way around this by creating some kind of helper method on the struct and blah 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 blah. It's technically possible, but that introduces a layer of indirection to not just our implementation but also to the user stuff. So I think it's just totally fine in my opinion to tell the user that specify exactly the struct you're linking to, right? So this just provides us a lot of things to introspect at compile time, so we can give the user more power to do stuff. So in the case where we have this, we would actually be more interested in this type. So like I mentioned here, for this um, we're interested in this bt, right? Here we're interested in this. However, in this place we would be interested in not this. I'm just gonna steal that from Copilot. We're interested in this instead, and I'm gonna tell you why. If we want to specify metadata like that enhances a lot of stuff, let's say we want to do something like implement uh, I need to show you that part of the code for you to really understand. But just think about a scenario where we need to implement something on the current struct. It's gonna be company blah blah blah, right? And we say users, right? Actually, for the way we're working with our query building, if you want to get like the basically access the graph you want to traverse, we would be more interested in this because I can show you in the parser. If you go down a little bit, or oh, actually, let's go to Node. The way it works is so we define a schema definition here, right? And basically we alias that to the struct name. Technically, under the hood, there are two different stuff. Let's say we have a user. The first one is for the data, which would serialize into the database itself. But the second one is for the schema itself. There is a distinction. This is responsible for getting the field names and properties and stuff like that. So on this schema, we want to be able to access foreign fields, and in that kind of scenario, for example, here we pass in all the linked records. So in this kind of scenario where we have user, it would be something like this, right? And if we would use linked many user, now you see the limitation. We wouldn't be able to do some. We don't want to do this, and even though we could parse the type within this link many type, that wouldn't work for a situation whereby a user does an aliasing or whatever. So in that kind of situation, it makes more sense for us to just tell the user to specify the link table type here directly, so we can just take that and use it. But I'll show you an extra complexity that comes in when you're now dealing with a relation. A relation is kind of like different. Links are more straightforward because they are like direct links to foreign tables, right? But when you're dealing with relation, you can think of relation like in a relational database management system, you can think about it like the third level normalization, whereby you have the bridge table. So let's say you have a product and you have the location, right? And you want to be able to like connect the two. Then you create a bridge table, you normalize them. So you take the primary key of product and you take the primary key of location, then you create a bridge table, right? It's exact concept you can think of in graph. You have the origin node and you have the destination node, then the connection would be the bridge table. So in this kind of scenario, it's get a little bit more complicated because now you're dealing with not just two or so for user you're essentially dealing with the origin and destination. So that would be company and user. However, for the relation, you're dealing with actually three structs. You're dealing with the origin struct. You're dealing with the um the connection edge. You're dealing with the edge itself, the edge struct, and you're also dealing with the destination. So you have the the nodes, origin node, the edge, which is the connection between the origin node and destination. In this case, it would be company, it would be like, and it would be user. This gets a little bit more complicated because now suddenly you're interested in, so you're able to get company metadata, right? But you're also interested in like, and you're also interested in user. But here's the thing. Imagine a situation whereby we've got generics here, and so we have something similar, like we're inheriting from the struct, right? We've got something like this. In this kind of scenario, it's actually there's a complexity that might not be apparent like immediately. How do you tell which um which generics which of the generics is being used by like or user? It's impossible to tell that just from this. I'm sure we can also do the same thing, create some metadata on this struct, um, and we can access our compile time. But the way I'm looking to get around this, I was thinking through this while I was sleeping. The idea came to my mind. So let's use this heuristic. If you're gonna have this kind of situation, this kind of scenario, right? User is gonna have its own generics, right? So let's say user generics is gonna be just T. Let's start with T, right? From that, we are able to sort out user. So even if a user does like an aliasing, or let's say the user does something like related type, related user. Although this wouldn't be encouraged, right? So let's say you've got relate user, and you use this here instead. Let's just comment this out. So that would be related user. So let's think this through. Like, I'm thinking through this as we're just working. In this kind of scenario, what you're gonna notice is that now we are able to do some disambiguation. So we're able to sort out user basically. That way we're just gonna get the destination string, which is gonna be user. So get the identifier and say user, and we expect that to be let's say user, and then we could just take the generics used here. So that would be A and that would be T. So we can use that type. So we need these, let's say one, one of the things we need. Then we also need, we have the origin node, that would be company. So we have the company, then we need the like. So let's say for like, how do we get the stuff for like? And one idea that came to mind is for that, let me be sure that I remember this idea that came to my mind. What we can do to get around that. For like, we could. User gets that. Oh yeah, so for like, right? We can basically just use generics here, because so for like all we need is this. So like we take this because like is the bridge, and since this is the bridge, let's say bridge or link, or let's call it edge or link between origin and destination or target, yeah, destination nodes. So because of that, it means that the link or the edge or the bridge between the origin and destination node has to be a, if you think about it, in form of a set, right? Let's use the set theorem here. The like would be a union, the likes generic would be a union of the origin generics and the destination generics, right? So in this scenario, the generics for like would actually, technically, this would actually involve you also, since you're using company. This would also include you. So this would be a union of the two. And in the, let's make this a little bit more complex. Let's say user has an extra generic, and that is you, right? So this could be this. The like would be union of the origin generics and the destination generics. But the user, we can directly get that from the field, and the origin, of course, we've got that. So when we're dealing with like a graph, an indirect link, it's a little bit more like complex, and I'm actually thinking through this as I'm working, right? So the metadata we're gonna need from this is we need the raw field type, and that suffices. And here we're gonna need raw field type also. That's totally good. But here we are actually gonna need to multiple stuff. We can take the raw field type, link field type, and when we're dealing with relation, it's a little bit more involved. Here we're gonna need so here we need raw field type also. But for relation, we're actually gonna need the edge field type, edge field type, let's say, with generics, and we're also gonna need the destination node field type or foreign table. Um, it doesn't actually have to be foreign table because we could actually have um, okay, that would be on the other side. Anyway, let's not use the word foreign because you could have like link self. So let's say you could have something like this that says, let's say headquarter or something like, I don't know. Or we put branch and that says link one. Actually, this would be link self. In that case, this would be company with all the generics. And no, actually, this should go here. Link self, and this would be link self, and this would just be self. You could actually do this, that would be fine. So you start to see a lot of difference, but I'm actually thinking through this as I'm working. So let's comment this out and let's start implementing. So one thing I'm looking to do is tie this metadata stuff to the relation. So currently we've got this relation and we are just generally using we're sharing this link rod field type, and in relate is a little bit different, and I suspect that in link self is going to be also different because in link self you can actually use self, and we need to undo that edge case. But anyway, first let's see how we're using this. So we go if we go down here, let's go. Okay, it's mostly it. Let's see in link menu, for example, we're updating the serialized field type. We're updating the link field type, and what does that say? The name of all fields that are linked. Okay. So link one, link many, link cell. List of serialized field name actually. Okay, that makes sense. And also the field names. So in this kind of scenario now, previously we were passing the identifier directly. So let's say the identifier could be user. But the problem with that is if you use like a generic, then that's not handled. But now we're passing the type directly, which is nice, right? However, when you have link many, we actually don't want to use the field type itself. As you can see, this is taking the linked field type. We don't want to use the raw field type, as I just demonstrated here. If you have like link many, yeah, like we do here, we are not interested in this kind. Like you don't want to put like link many. Like you wouldn't. Let's take this there. Let's go back to where we were here. You wouldn't want to have something like this. In the true sense, sorry, what just happened? in the real sense, you don't want to have something like that. We just up and down. You don't want to have something like this. You rather want to have something like this. So let's take that up. You're interested in having something like this, which is why we want to take the linked field. And when you're dealing with relation, it actually gets a little bit tricky. It gets trickier, but anyway, I just wanted to explain, give a background to what I'm doing, so it's a little bit clear. You don't get confused as to what I'm trying to achieve. Basically, that's it. Yeah. So I guess to tell you what. So right here, I'm just saying linked field type. I might as well. I might as well just let's check this custom type, right? But this the type no self. Um, I might as well create multiple kind of links, right? So what do I mean? Currently I'm using this single link type, but I could also have, what if I do link one, and rather than taking this, because link one should link to a foreign field typically. um, Technically you can use it to link to the current struct, but you're gonna run into an issue because we need to box it, right? Otherwise, um, if we put it on the stack, it's not gonna work. So the way we is that we need to box it to put that in the heap, because we're doing like self-referential typing. So I'll just rather take custom type, right? That's link one. Then we have link self. Link self can actually just take Rust type self, because you would have self in it. And then we could have link many, and then you also have like nested objects. Typically these should um this should take a custom type, I'd say custom type, and then yeah, also custom type. But for relate, it's actually gonna be a little bit different. um so relate is gonna be a little bit different, and let's just copy this. Bam, bam. So we go to relation. We've got this, we're passing in relate, so we can put that within this. And so we've got the model, the type you're passing in, and one other stuff. So we've got the model, but one thing I would also want us to have, so this could actually just be the custom type directly. And so we need the, for the model, it's gonna be the edge model. So I could call this like edge model. That's more like appropriate. But we also want for like the destination type. So this, let's call it destination model, and that could just be custom type. Technically you can relate to the current table, so you can also have like Rust self allowed, and I think I'm not exporting custom type. Let's do that. Yep, let's import this. Um, so this would be um, let's copy this. An example of destination model would be book, and these would be uh, e.g. book derived from this. So mm, then yeah, it's gonna be also of course also book, actually book with generics or something like that derived from. So that's edge model and this is the destination model. So we'll do a little bit of refactoring here and so this we actually want to use something more specific. So let's say we're using link one raw field type. This gives us more flexibility. Link self. Then this is link many, and this is nest object. Yep, and this is nest array. Even though they have very close similarities, and we wanna um, differentiate them. So we've got this Anurag and Mishra. I hope I got the pronunciation. Hey, I'm new to Go. I just learned basics of Go, so could you suggest the resources for learning backend in Go? Um, that's a good question. Resources for learning backend in Go. I would say GitHub. Just work on projects you find exciting. That would be my best recommendation. Just work on things you find exciting, and I think that would be great. Um, yeah. Go through the official documentation. Once you and Go has very tiny surface API, so API surface rather. So just try to understand the basic, the syntax, control flows, and that all that's around lane. Once you understand the basics, just start working on projects. That would be my recommendation. So if you really think about this, if we want to make this more robust, let's see how we're using this conversion for relation type. Um, let's tie all the implementation together. So currently we're using this link one Rust field type. Um, what if we actually try to differentiate? So what do I mean by that? We have the link attribute type and the raw field type. So if we try to do something like struct um, struct, what could I name that? Field type meta. So we have the attribute type. Let's make it pub grade. We have the attribute type. Attribute type, then that would just be like it could be custom type, right? And we also have main type or raw main type. So let's call that main type, because when you're linking you have both the main type and attribute type, and um so one thing we could do for sure is
I'm just trying to think through the implementation details. So, for example, for sure we could have, when we go to relation, we could use, let's say something like this. Um, example, we could use structs dev like we do main type, and take custom type. Then we could have also um, attribute type. Then so we could have this. But one thing I'm thinking of is in this kind of scenario, they wouldn't be able to have like in this kind of in this current implementation, we could implement specific method on each of them. But if we go to the parser, I really don't think we're doing that anyway. I really don't think we're doing that anyway, so we might as well just use structs. We can use like struct reference. So if I go to parser, let's get the reference of this here. So this we could actually, I think it's better to, let me see if we're using relation in multiple places. Are we? Let's, yeah, we are. So that, yeah, 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 makes sense. The benefit of doing this is if we go to our field receiver, let's scroll up. So in this area now we could basically just pass that data here directly, and if we would pass in the struct to the enum members, we wouldn't be able to leverage this, right? So that's one benefit of using a wrapper struct like this over just directly defining the things you need within this. So the benefit of this over this doesn't give us the benefit of but is that a problem though? Because actually that might actually be what we want. Because um, if we go to let's think this through before we make the decision. If we go to this receiver, anyway, this is the receiver type, right? So this could just be the link type, and but in the case of relates, then we've got the relation where it's kind of different, right? Because we already have this type and we've got that. So we'll always have this separately anyways. Um, but sometimes we don't. So yeah, in that kind of scenario, it might actually not be problematic, and it can reduce the complexity of our code. So we just have like link Rust field type here. Because if we would make them all unique, then it starts to become unnecessarily complex. We are introducing unnecessary complexity into our code base, and I don't think it's worth it. So we could call this like attribute type or link type, just like where we currently. So, but for relate, it's gonna be a little bit different. We're gonna need the edge. So it's gonna be actually edge link type. Edge and that. Okay, so these are mostly focused on the relation. Of course, we can take the. I'm trying to think through this a little bit. If we should put the main raw type with the link type. I guess the benefit of that is that we can undo self transformation together. So if I show you an example, I think we're here, right? If you're linking to self, for example, we have self. Rather than saying company, you can actually just say self. The same way we have this here. So that could be one benefit of doing that. We can put them together because we can deterministically tell when self would be used. But when you have a link many, you could as well have self. So, or should we always assume that self can be used? I think that would be a safer choice. Just by default, assume that we can always have self. So here we go. It's getting a little bit too odd for me. Link, field type, link field type. Yep. Link field type, and this would be relate, right? So here we have two stuff. We have the edge model, and we also have the destination model. I guess if we go to link, field type, the references, rows type, self allowed. Um, um, what if we just do, okay, because I'm trying to differentiate between the two. When you have to sell, okay, anyway, I'm just gonna simplify this. I think it's not very necessary to have this separately, right? We can just assume that it can all have self and transform that when we don't need self. So it should be with self and without self. Um, let's think. Yep. So why we do it on custom type? So we can just have custom type and custom type no self. I think that kind of differentiation might actually make sense instead of trying to say the naming of custom type and custom type no self is looking more appealing to me. So we do, I mean, we could have this, but what if we do custom type because no self? So you can convert from the basic type, from implement from type, you know what, you can implement from yep, and we can actually take, oh, we need this extra stuff.
so that's not gonna fly. But I guess we can take this custom type and implement this method on it instead. So let's bring that, and you know what, we're just gonna copy everything and take it to custom type no self implementation. So yeah, we have that. Then we can, at least that should be fine for now. Yep. So pretty much everywhere, I guess we could have custom type no self, and we could have link Ross field type. Link Ross field type. What else do we need? We also need let's use link Ross no self. Right. I think yeah, we can now use custom type no self. Then let's have another one called link Ross field type no self. This will be just custom type, and with this implementation we can do to replace self with current struct, something like that. Actually, this method should be on basic custom type, right? So we take this, it should be here, and we're gonna do custom type no self, and so this returns type. Let's make sure that we can convert okay, let's yeah, we'll clean all this up later on. Custom type no self, let's go there and let's new. Yep. So we can basically come here and do custom type no self new. Yep. Yep, that looks good to me. That way we can transform. We can call this to type no self or replace self with current struct. Replace self with current struct ident. Yep. So we got that.
custom type, got that. All right, so we have the Ross field type can be called maybe main field type, right? Let's call this main field type. Um, main main field type. Oh, my renaming is messing up. Oh my god, it's a disaster. Anyway, so let's let's visit generics. Straight bounds. Okay, let's go to field generics again. Get generics meta. So with this generics meta, I'm thinking if I should make that unique also, but that might be an overkill. That might be that might be an overkill. So you know what? Let's leave this out for now. Let's close everything first. Save this. Save that. And save this. Close that first. So here we got relate. We got link one field type. Custom type. We want to be able to differentiate when we're using the main field type and link type. So here we can just revert this to link link attribute type. Let's try to rename that to link attribute type. Do we have any of that? So we can have, okay, I believe it's this. So we can have this and this, and I'll call this link attribute field type, and I'm gonna call so no self, no self allowed. I'll call this original. Original. Naming is bad. Damn. Original. Then this one without self. No self. And here we're taking custom type no self. And on these we can delegate replace self with constructs. But actually we would want to do link
here. Actually, I want to say link attribute. Select type original and link type. Link attribute. Link attribute. Yep, so that's the original. Then we can take that to no self. So from this we can always get the other one. Just delegate. With that, we don't really need all this. We don't really need all these. Yeah, we can remove all that. Yeah. Remove all that. One thing I'm actually contemplating on is if we call like which name is better. I'm struggling with the naming convention here. One other naming convention that came to my mind is to actually focus on what they're doing. So this can also be destination, because actually this is what we're ultimately focused on. Destination node type original. How about that? Destination node type original. So rather than focusing on the implementation or detail of the attribute, we actually focus on what this is. So this is the destination node, and not everything has a destination node. So this could be then destination node no self, right? Destination node type no self used. um, yeah. Anyway, we'll come back to we'll rethink that. So we want to implement two tokens here, and I think it's probably better to do something like to type. We should have to or should I implement the ref? That could lead to a lot of issue. Let's just delegate. Yeah, we like to type to basic type. Don't we have that? Do we actually want to implement the ref for it? We'll rethink that later. To basic type. Let's do that here. So type name. I think this should be on custom type. Custom type. Type name. Yep. Type name. Yep. Okay, yeah, let's put it there. Then Ross field type, no self. Let's just take that off. Custom type, no self. Okay, then also let's delegate type name there. So let's just do type name. Yep. Um, yep, 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 yep. So now we've got um, destination node. This should be called destination node type original. And just try to copy that. Destination node original. We'll just remove that and so we can take that and yep. Um, yep, 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 yep. Prepare save that gives us these. Um, mm, mm. So this gives us custom type no save. Okay, it's fine. Then we want to do so tokens custom type no save. I guess we could delegate to basic type, or don't we have that? Yeah, we do. And custom type no self. Oh, why don't you just put implementations together? So if we do this, why doesn't let's see, does this also have the basic type? Perhaps we could just do custom type. So basic. What? I don't know. What's wrong with you? Yep. Rest type myself. I was still using this is irrelevant. So basically we're trying to convert the type to path, right? I don't think we really need this first type, no file. I'm just gonna take that out. So we have the custom type, we have the custom type myself, and so maybe I could do something like type custom type links and type main. Sometimes gonna help us simplify things a little bit. Let's see how many lines. It's just oh no, oh it's already getting large. Custom type. So why we take all these? I think we take that to type custom and mm, yep. So we have type custom and maybe I could call it Ross type. Because we have DB type and we also have like so, so I'd like this to actually be Rust type. Let's see, I could go to main and change this to okay, it's renamed now. Rust type. Yep. And type main. Type main could be naming things can be hard. Okay, we go to type first. Yes, we probably need. Let's just take out that. And main, let's go back to type first. And we're gonna take main would be, I think for that we could actually just use basic type I don't see why we need to. Yeah, we don't need to. We can just use that as the foundational stuff, and this second one could be. So rather than having that, we could actually let's type links. A destination link attribute. So we go here. We can copy mostly just. So I've just renamed that as actually. So let's delete that. Let's delete that. Field raw type. Rows type custom. Rows type links. Link attributes. Yep. Then we go to the link attribute now. Let's see what we can. We can remove that. We have token for these. To basic type tokens. That's for the destination type. No cell. Yep. Destination type original. Sometimes you can have cell and Yep. Let's implement the tokens for that also. Yep. That's fine. Okay. Don't wake me up when he's all over. When I'm wiser and I'm older. All the time I was feeling myself now. I didn't know I was wrong. I can actually strip lifetime. What if I move this directly to type custom? Mm, I do. Custom type and I do custom type ref 5 times stripped. Yep, looks good. Type strip or yep. So we have that. Um, yep, that's probably fine. Um, I think we actually don't need this, but we'll keep it in the meantime. We don't need it anymore because I implemented a custom static assertion that allows generics and lifetime. I was previously using the static assertion library, but it doesn't support generics and lifetime, so I already sorted that out, so we're good. And we have field receiver. We'll come back to that. Huh? Well, um, field receiver generics. So I might as well call this field receiver generics. We go to field generics. Yeah, probably fine to just call it field receiver generics. As generics, get field type generics meta. So we get a struct identifier, we get a generics. Then we use the generics extractor. We are custom generics stripped. I'd like to call this stripped and generics. Stripped and generics. Stripped and generics.
Yep. So let's struct generics, few generics. So we're using this generic structure. Because I'm actually contemplating if this should if this should go directly as method to custom type. Mm, same few generics. My laptop is running low. Generics type extractor. Yeah. Let's see the places where we're using this. Mostly, let's see if it generics within this module. We're also using it on few generics. Where is it? Okay, I think this could probably go on the custom type itself, right? So on custom type, we might just have generics extractor. Yeah. Yep. 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 Mm. The two train is 7. We go to custom type. I think that's a decent place to have it. Let's go. Yeah. Yeah. We could have. Could do get field generics meta. And this is yeah. So this is actually going to simplify the logic a lot more because we don't have to really care so much. We can just focus on the fact that stakes field type. We can delete all this now. Replacing self or no self, it doesn't really matter. We can just focus on passing maybe into and out to basic type, and that gives us everything we need. So now we're focusing on the type itself, and rather than saying get generics meta, because we need this is just like get generics meta. It doesn't matter. We're not focused on the implementation detail um, of the type now. We're just focused on the type itself. We're not focused on the distinction. We just want to get generics metadata. Um, so that is that. But we want to make sure that um, yeah, these are related to fields. It needs the table attributes because we want to make sure that every generic we're extracting can be
derived from the struct because it has to inherit from the struct, right? So we have to make sure of that. And if you really think about it, that doesn't that doesn't actually matter, because if you're trying to define your if you're trying to define your type anyway on the field. So let me show you what I mean. So let's say you've got let's bring this up a little bit. So let's say you've got weapon, user, weapon. Let's say you've got user, right? And user has generics. A could be whatever. T U plan plan. You've got something like this, right? We don't need to do the extra check that, and I need to confirm. We don't need to make sure that this generic is used on the struct, because anyway Russ is gonna catch that. Oh, Brett Hagen, that's a good question. I actually don't work for Surreal, which is interesting, right? So this is just my own project, and I've been working on this project for 14 months actually. I started in December 2022. 2022. So I don't work for Surreal. DB. This is my own personal project, and even though I'm supporting Surreal DB first, I have plans to support Postgres, like basically SQL databases, Postgres, MySQL, SQLite, and even like I can see the possibility of supporting MongoDB. So I don't work for them. I have no affiliation. I have no relation or relationship with them. I'm just one man trying to make my own life easy, a little bit easier, and trying to share that with other people. So this is my own personal project. Or what do you think about that? And I've been putting up. I put probably more than 4,000 hours. So I'll be back in a second. I need to get my charger. Yep. Now we're plugged in. I'm back again. So if you really think about it, this. Oh, I think I remember why I'm doing that. The reason I'm doing that is we might want to get the. So you can think about these could be, let's say, default, or like you could have something like where, let's just use a mixture of both. You could even have this and plus default. You've got something like this. Yeah, I remember why we're doing that. When you're extracting the metadata, you want to get not just the generics, like you're not trying to get B and T, but you want this, you want this, and you in fact also want this, and if you're using B, you would also want B. You would also want that, and we need the struct metadata to do that. So that's why I'm having that there. So we're getting the metadata, extracting it from. So we're extracting from the struct, the implementation, so that we could use that within an implementation block. We're getting the type generics, which we could directly use after the struct name or identifier, and we're getting the where clause. So this way,
We support everything you can imagine. So Old Lazy Lobster. That's a beautiful name. Hey bro, I'm also starting with Rust. That's wonderful. What got you interested in Rust? How did you find the channel? Where are you chatting from? And thanks for joining the stream. I appreciate you for joining. I think you are the only YouTuber using Rust with this kind of stream. What do you mean by that? Do you mean like doing Rust or having a very disorganized stream? But I appreciate that. It means a lot to me. Um, and I'll also appreciate if you guys can help to share the channel with your friends, anyone, if you find value um, in it. Oh, for smart contract. That's cool. That's cool. So I mean, if you're working with smart contract, there are like multiple stuff. Even in Ethereum, there is Ion framework, and obviously, um, Polkadot uses Substrate, which is written in Rust, and also Cardano has some Rust modules. Solana is written in Rust, and I think Sui and the rest of them are like using Rust. So that's cool. I hope it works out. So you can write some not just smart contract but secure contract. Because writing contract, I think in um we've got Viper, which is Python, and we also have the de facto, the popular one, which is basically JavaScript. They are not very safe. We also have like some other stuff. Yep. So from these we can basically get type generics meta, because we need that. Um, let's remove that. How do you want me to help you? How may I help you? Custom type. Um, okay, that looks good. Where should you start learning from? Read the official Rust book, read Programming in Rust, starts, jump off the cliff and figure it out. I don't really know a good Rust course, to be honest, right now, and that's why I'm trying to finish this project on time so I could create some courses that I feel like I would love to have myself. That would have saved me so much time. Because I spent a lot of time trying to figure out a lot of things, but that's also a good thing because you get to explore. You get to explore and you learn a lot when you're exploring. Replace. Dun, dun. Yep. Okay. Yep. So I think we're good with these now. Let's look at these. This is also probably okay. We need to update these. For Meta 21, we get type destination node original. We just get custom type. No. Okay, yeah, we got new. That's good. Yep. So we're able to parse that. Hmm. Actually, so we are actually we shouldn't be doing this anymore. This is not the way to go because we're getting the identifier alone and trying to convert that into a type, and that's not a good idea. What we actually want to do is let's go to custom type first. We want to implement. Let's go. Yeah, I believe we could just do um, from derive from meta. Yeah. It takes path, it takes list, and um, I guess just wondering if we could take error type. Okay, you know what? I'm gonna try this. We go to field receiver, destination, node original. Mm. This can be a custom type. Mm. come back to this creativity type with your sessions and just by saying I love you. So generics, custom generics, blah blah blah, stripped, strip that, we take the type, we generic param, yep. So here we strip the bounds and yep, yep. And we have the remove the word clause, we take the strip params and we take all the stuff from that. It's good. What's happening? Struct generics. Okay. Struct generics and viewed generics. Is that differentiation necessary? That's less well using that. Extract generics for complex style. Honestly, I think it's just better to do extract generics, make these yeah, I think it's better to just do something like this and yeah, you have that. Actually, let's take that off. Let's make it a static method. So we could instead take
this is gonna be generics. Generics. Extract generics for complex type. Let's see the usage, for example, here. How about we a lifetime if not exist. But we're mostly not gonna be dealing with generics alone. But the type. So for example, we're doing this on the type. Let me see other context where we're using generics. Extractor. What if I think it's gonna actually be better that let's close everything else, save this and we go to custom type. So we're doing get generics meta. That's fine. If we want to just put everything in a place, that's totally fine. We could do that, and maybe we should. Alternatively, we can I should call these res generics extractor. Alright, so we go here now. There's more to this, so we go down here, and we could implement the custom type here and do everything here, but I think it's actually good the way we have it, so we can put all the logic for extracting generics here, and yep, I guess we can just have the type. Yeah. Yeah, doesn't even matter because it can be any type. I think it's not a big of a deal. So we go to custom type. Now this is gonna be extract. Bam, 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 bam. This says extract the person there. Struct generics, but actually expects this. What's this? Maybe we could pass in table attributes. Let's see.
I think it's just easier to just pass in table attributes and yep, got generics there and this. And even this we could just pass in, I don't know, custom type. And okay. Field type. We might actually want to do this so we don't. I want to clone the field type. If I remember correctly, the CVC type. I might have to restart my editor, but yeah, it might be a good idea to. Oh, this is gonna be generics. Okay, yep. So, does this? Yes. So this mutates. Okay, it mutates that. Where's the type? Okay. Where's the type path? Let's see. Okay. And that takes the binding. I guess it mutates that. Binding comes from. Okay, yeah. Yep, 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 yep. So I got that. Every night in my dreams, I see you, I feel you. That is how I know you go on.
Okay, yep. So we initialize that and we call visit type. Visit type call visit type, which calls all these other ones. Okay. But we want to mutate these. I mean, we hold on. Actually, we don't even need to do these because it's mutating the generation instead. So, it's a basic type. And we close that. And that's good. Thinking if I should create wrappers around this, but maybe not so necessary. Because we're gonna also need this for like, we're gonna need it for the links, and we're also gonna need it for the main types for the field. Um, so we might consider a distinction. Anyway, so let's look at this. Um, okay, we need to remove or it should be example. But anyway, we can just take it off. That's fine, and this could be, I believe, destination node original. Bam, bam, bam. Yep, that is fine. That is fine. Okay. Not even don't need that anymore. Edge type. Are we using this anyway? Ah, interesting. Edge type. I believe we could probably just take this off. Now we got something better. Yep. And this should probably use a try from. Do try from. What if we do this? And the error could be instead. Should we make these syntax error, darling error? I think syn error better. Actually, structure. Yeah, we could return error. Invalid relation. But
check this out. To sync error here. Um, second span. Paul Millsap was good. You seem committed. Do you do two a day often? You mean the stream, right? You mean the stream? I really don't have schedule. Like my life, my lifestyle is quite chaotic. So like I could wake up in the middle of the night. I just stream when I I have the energy to. So it could be I've done a lot of streams. If you check my past streams, I've done a lot of streams in the middle of the night. I could wake up early in the morning. I stream before I go to the gym or before I go shower when I'm back. So I really don't. I don't really like. I have like crazy routine. I just make sure I try to knock out significant amount of work done when I have the time. Um, I usually have the energy, but when I'm traveling and I'm not able to work a lot, that's different. But when I'm a little bit like stable where I am, I stream whenever, wherever I can. It could be in the library. So I just I'm just trying to get things done. Yeah, man. I think productivity and this task is CL is all that's syntactic sugar good. What do you mean by CL? Yeah. Um. Let's um. Coside. What was the message here? I forgot. Um. I could say invalid arrow direction usage should be only. Then since we want to return extractor error, we could just do that because we have a converter. Um, oh, okay. Now, sorry. I don't even know. This, I I should know that. Yeah, man. I think productivity and this task is cool. Is all that syntactic sugar? Yeah, I totally agree. Yeah, I need to catch up with all those test speaking. What's good? How are you doing today? And I appreciate you for joining in again. I remember. I remember. I remember. So yeah, we could also return return an error that takes this and maybe not that too many actions or objects. Um, what does that even mean? Oh, what was I doing here? Um, it should be um too many. What's
Doesn't make any sense. Am I even using this anywhere? Thank goodness. Let's take it off. How should we? Actually, I'm gonna leave that in the meantime. Um, too many notes, too many edges or notes. Um, you my remedy. Okay. Sorry, sorry without sounding incompetent and too lazy. No way, you're not. Can can help describe some fundamentals or governing principles of graph theory relates to what your algo intends to accomplish. You have multiple builds, 2 out of 2 on GitHub. I'm not sure what you mean by multiple builds. In terms of like graph theory, um, what my algo intends to accomplish. So you can think of what I'm trying to accomplish as like so what actually birthed this project. I've worked with a lot of ORMs and a lot of query builders across languages. In TypeScript, I've used I don't know more than 10 ORMs. I've worked with ORMs in Java, in Ruby, in Python, in Golang, Elixir, and I actually tried like maybe at least 10 ORMs in Rust. Where do you store or host your code base if it's not already running locally? My code is on GitHub, right? Or like if you mean hosting this would be on Crate.io, but you can directly reference it on GitHub. But if you mean my normal other projects, I've used Linode and Etna. I don't know if that's what you mean, and I containerize my stuff. I spin it up in Kubernetes, and that's what I usually do. But if you mean like hosting this library code, I just like put it on GitHub, and once I'm done, I want to be done with alpha before I publish on Crate.io. So I'm hoping that before this month runs out, basically when we're done with this, I'm gonna launch it on Crate.io. Then I will do a release note and announcement and do a crash course on a proper long course, finish the book, then share it on different platforms. But yeah, regarding the graph stuff you were talking about, so the whole idea is if you really think about data, I think the implementation detail of the database engine is a completely different stuff, right? So if the database is whether it's SQL like log structured binary tree or whatever it uses in the implementation detail, that's a completely different stuff. It's what it needs to actually make the database engine works, right? But we have the next layer of abstraction, which is how you um, interact with the database. And in my opinion, I think if you're working with data, graph is the ultimate data structure. If you think about it, you think about graph being the ultimate data structure, the super data structure, right? Then it it's it's in my opinion the best abstraction to build the best paradigm to build um, the optimal abstraction on. And what do I mean by this? If you're working with graph database, we have like nodes, we have edges, we have connections, and all that. But you can also adapt the same thing in normal relational database management system, regardless of the implementation detail of the database engine. You have like different levels of normalization, right? You have the first level normalization, you have the second, third, and fourth, right? Let's go to the worst case or extreme. Let's say the fourth level, right? Basically, what happens in the first level? You have two tables, and you want to relate these two tables. They have like many to many relationship, right? Many to many. You can think of it like let's say we have a user table and we have um, a subject table. So we've got two tables now. A single user can have can take multiple subjects, right? And a single subject can be taken by multiple users. That's a many to many relationship, right? And that's where you apply the fourth level normalization, where you bring in the bridge table. You take in the so you have like a composite primary key, which is like combination of the primary key from the first table and the second table. These are relational database management system implementation details. But when you're really thinking about your data modeling or abstraction from the tooling, which is what I'm doing now, you can take that fourth level of normalization, which is like the extreme case, where you have like many to many in a relational database management system, and map it to a graph thinking. Essentially, the fourth level normalization is just talking about a graph. You have the user and you have the subject. A user takes a subject. A subject can be taken by a user. Take is now a separate table, and that is what we call a brick table in the fourth level of normalization in the database system. So we can talk about normalization and the data denormalization. Um, so then if you think about that, regardless of whether you're using like Postgres or you're using ArangoDB or SurrealDB, which are like graph databases, or Neo4j, if we're gonna build an abstraction, I want it to apply fluidly across different database system or paradigms. Then graph, in my opinion, is what will give us the most flexible and generic abstraction that would map out easily and would be easy to think about. And if you really think about it, um, data by its nature is relational. Every data, every you can think of every like database management as graph. That's the ultimate, because when you're dealing with data, inherently we're saying relational database. That is graph. Like graph is what talks about relation. I mean, when you have like a tree, also that's tree is basically like it's basically a graph. You can think of it like a subset of a graph, and mostly you can apply other data structures when you're dealing with graph. So that was what led to this work. I was trying to think from, rather than thinking about in terms of best practices, I started thinking like from first principles. Why can't we rethink the way we model our abstraction on databases? And what's the best paradigm to use for that? And that was what led me to focus on graphs. So now when I'm supporting Postgres and the rest of them, I can apply the same API that I'm applying here. The implementation detail of the API might differ. So for example, when you're using SurrealDB, you use the concept of like relating a table to another or linking. But when we're using Postgres or MySQL, we can use the concept of join. But when you're using the query builder, you can use like join keyword, right? That's fine, because I'm trying to move you as closer as possible to the raw syntax, and I actually support like static checking of the raw types, right? However, when we're dealing with the ORM part, like basically mapping the object to the database schema, and
In that aspect, then I will be still be using, I will be retaining the concept of nodes and edges, right? So a node would just be a normal table, and an edge would be a bridge table, right? So that's the way I'm thinking about it. So when you're having a one-to-many relationship, that's gonna be a direct link, right? So we already have the concept of link many. That's a one-to-many relationship. We already have link self or link one. That's a one-to-one relationship. It could be when you're doing a join to a foreign table or inner join, yeah, self joining to the table. Then relate would then apply to the fourth level of normalization that I mentioned, which would basically be having many to many relationship between two tables. And when you think about user taking many subject, take would then be the action word, which is the edge, right? The connection, the edge between the two nodes. So that's the philosophy that I'm using to any okay, any good premiers for understanding graph theory? Could you link, please? Um, what would be a good resource? I think just maybe googling and watching different videos might actually help. You might find some, like, I think just watching some videos on YouTube would be helpful. Find different videos on that and see the one that works best for you. I think. Or what do you think? Um, so we've got this, and that looks good. Mm, Anyway, let's simplify generic extractor usage directly using constructor implementation. Let's see. A second. Think. Okay, I'm gonna leave this for a while. Oh, I should actually comment this out. Um, oh, okay, yeah. Oh, okay. So action item scope is limited and extensive. Or is that much? Could you? Yeah. To 30. I just feel like graph theory math is too advanced for me. I think the what works for you might be different, but what usually works for me is um, I really like first principles thinking and understanding why. I'm a very inquisitive person and curious person, so understanding why. If something is very simple and I can't really understand why I'm doing it, why we're doing it in the first place, it's gonna be hard for me to grasp. But if it's much more complex, but I understand the why behind it, the rationale, then it becomes easier. And um, a very good way to have a rationale behind something is to actually have that problem you're trying to solve or a problem you're interested in. So you have context around it, and it's easier for you to figure things around that way. Uh, But if you don't really find the application of what you're trying to learn, then it becomes much more difficult for you to wrap your head around it. At least that's the way it works for me. So you might find that something else works for you. So let's push that. Um, let's go to name. Okay, this is good. Name normalized. Field name normalized. Is ID. Is our hedge. Okay, that looks good. Oh, is this the same? I think. Um, Maybe this should probably be field casing. Let's field meta. Am I using this anyway? Reference. Okay. Field name normalized. Interesting. And am I using this other one? Normalized meta. I think we want to use either of these. So field name normalized as that. Interesting. Should it be called name normalized or get DB with assertion? Okay. Field name normalized infer types. Let's see where we're using this. Is ID okay? So field ident serialized probably makes more sense here. Field ident serialized format. Just field ident. Okay. Serialized.
is that just name it in. Okay. Yeah, I mean, we could also use like the rename attributes, which is what we're using. Yeah, but this makes this work in case you're not using the rename attribute, but you should. I guess that's okay. Yes, so this was what I was talking about. If we go to permission, we're implementing the tokens for permission. So with that, we really don't need this anymore. And take that off. Take that off. Yeah. And for assert, we're still taking literal string, but I think we. That's a mistake. Basically, we want to take an expression here also. We don't really need to do anything crazy. Like, let's see for permission, because permission can be much more complex. You can also have none and stuff like that. That's why we're doing it. But for assertion, we can just take an expression. Take an expression. Do the same thing. Oh, actually, these should take a path. So this would take a. This would take a path. Anyway, check it out. Do we have it imported already? But anyway, let's just do the same path. Yep. Type. Okay, this looks good. Let's see what DB type looks like. Alright. And do we have two tokens implemented for that? Can we? Okay, we're getting the static assertion quite mainly that. Okay, that's fine. I think how we're using that, we need to think that through. I'll come back to that. I'll come back to that. Yeah, we have all this stuff now. If we go to assert, now we don't need to do this parsing. It gives us an error now. We could pretty much just pass in the assert. So this is an expression now, and this is a path, but
Yeah, we have to be sure that's gonna fly. You put in a path. Yep. Mm-hmm. But anyway, I'm just trying to simplify things quite a bit. So there's the permission. Um, what else do we have here? I feel like what's field type? Where's that come from? Type, db type, deref into field type. Did I remove the dereferencing? Oh yeah, I did. You know what? Actually, it does make sense to rather than derefing. Um, and this is not a static assertion. This is just the db type, right? That is what it is. So rather than doing that, what we could actually do is um, yeah, right. So you know what? We could rather than doing that, let's do a more idiomatic approach to that. We implement tokens, and tokens that extend delete token. Looks good. That way it becomes a lot easier to manage. So we get a field type on basically we have that and we could just do I knew I love you when you never know. Darling, it's you and me till we're letting go. Oh no, I'm so sorry for you. So everybody know. Darling, it's you and me till we let it go. You see, you won't let go. Hmm. That's a bit tricky because we need the values. You say you will let go. Say you will let go. Let go. I knew I love you when you never know. Only it's you and me. So okay, we're trying to get actually the static assertion. Mm, yeah, I might as well just take the whole thing. Yeah. Uh, you look away your shoulder for a minute. I was thinking concerning. I think you should get some rest. So I actually want to use maybe a method and call that get static assertion for values value attribute.
and you never know that is you to be great now. We've come too far, my dear. Look how we done. That is you to be great now. See you only good. Static sessions. Multiple values. Yeah. So when you could be sure for a minute. Oh wow, I'm doing that twice. That is insane. That is insane, really. That should just take like value. Wow. Hmm. So I wrote this song for you, so everybody knows. Till we gray know, say you go. Say you go. I'm actually thinking if I should have this wrapper TP type, but this is a good place to also have a value token. Let's just take this as token string for now. Oh, let's see. Value expression. Your love is beautiful and ever. Every day I pray you get better. You make me feel this way somehow. And you will love you. You never know. That is you and me too. Look how we find. That is you and me too. See you only go. See you only go.
implemented and type after. Well, this is a static assertion, so um, okay, it's probably better to have it here. So I wrote this song for you, so everybody knows. Time is young, but you agree no. Say you wanna go. Although, if you really think about this, it makes sense to have this on value itself because we're trying to validate value, not type. So it makes sense to have this as a method on value rather than db type. So let's see. There's the value function and mm, so this for you. Why would do something like this is what I'm thinking. Actually, one interesting thing we could, it's actually kind of interesting because we could take the same, yeah, I think this is what I'm gonna do. Although it might be a little bit confusing. Because there's really nothing stopping us from, even if you're gonna invoke function, you can take it into permissions and just do it without invoking.
and that would simplify a lot of things for us. So just say permissions, you could pass an expression to it, or you could pass a path into it, or you could just invoke something, you could just do whatever you want and it's just gonna work. Yeah, there's really no reason we need to do value FN. Um, yeah, there's, there's no reason we need to do that if you think about it. We could just take in permissions as, assert, value. We don't have to do value and value FN. We don't have to do assert and assert FN. We don't have to do permission and permissions FN. We don't have to do as and as FN because we can basically just allow you to pass in the identifier of the function anyway, or the path, or you can pass an expression and it's just gonna work. And you want to invoke the function also. It's an invoked function is an expression if it returns. So yeah, why not? There's no need to do that FN. It only complicates things. So with this in mind, I think I'm glad I came up with these thoughts because it's gonna simplify a lot of things in our implementation and cut down a lot of code and also reduce the indirection in our code. Let's just say some cleanup before consolidation of attribute with suffix. Yeah, this will really simplify things. Yeah, that's what I'm gonna do. That is what I'm gonna do. Togetherness is all that I'm after. Yep. So we're gonna take this off. That's gonna simplify a lot of things. We are gonna take this off, and we're gonna take this off. We're gonna take this off. Um, what else? Would that be all? We're gonna take this off. This would be um, permissions. So we can remove these. Yep, you see we're deleting a lot of code, right? Um, yep. Permissions, item asserts is, we're gonna change this to, cause it looks like we will be using a lot of somebody's assertion. Values get assertion. From meta, input that, and no, no. So expression and values. And there's path. So create an instance from a literal value of either create an instance from a literal value of either this displays the appropriate method. Meta, just take that, get the path, we just get the path. It's literal, we take that, and we parse that into a path also.
I think this should be applied to the same, so we can do expression of path, right, and expression of path. Okay, static assertion for value. Okay, and so let's say we've got value attribute. Let's convert this to and derive from meta. Okay. Value asserts as which other one? Receiver. Define. Okay. And define attributes. Um, the nature of this is to implement not that really but retire so I think this should actually go here. Okay.
generate static assertion.
And to do some push-ups. I just did 30 push-ups. Woo. Yep. So I'm actually kind of rethinking, cause I think we might want to separate those two. So this is inferring the type. And we're using could have inferred infer db type. And that also gives us that. If we're able to infer it, then we might, that's gonna be optional. The db type is gonna be optional. If we're able to infer it, then good. Otherwise, we're gonna fall back to whatever the user provides. So if it cannot be inferred, you would have to provide. In that case, we would have to throw an error. Okay, so let's check. So this generates static assertion for. So even if you provide it, it's still gonna check it against. Even if db type provided, it is still checked against the type to make sure it's compatible here. Yeah, at least it does best effort to under that. So here we're usually just expecting a string. Should we actually expect a string or a value? Because my concern is, I think with string we might be having to do something like type, and I might just change this to type. Yeah, I'm actually just change it to type. So that's something else we could do to improve quality of life. Refactor attributes to use, consolidate, and consolidate
Yes, I was thinking this might be accepting something like type equals. You might be having to do something like this, and I wouldn't want that to be the case. So I think we need to use from value, and at least from string literal no, we don't want all that. We shouldn't be taking path. We shouldn't be taking list. Yep. So we can take a named value. Oh no, actually, because when you say type, we're not gonna be having. Yeah. That's the name value. Path. We're not taking a name value actually. We are taking let's see, a name is because we're not trying to do something like type equals how would that even work? Like what would the value be? We're only trying to take a string function call linear s I think probably want to use it'd be nice to see what the default looks like. More than gold is all up to you. get DB type, okay, with assertion is infer or is the specified error. Okay, structure looks good. We can looks good. Ref node meta. Yep. So static assertion. Oh yeah. Even better. We don't need this anymore. So we can remove this. We can simplify this dramatically. And even this we could just basically do value get static assertion um get static assertion. Nope. What we need is actually this is a little bit misleading because this is now field type. It's not given. What we want here is field type and okay, field type, and actually this is db, and for the value expression we do yep, we could have done self, and since that actually implements the token, it should be fine. And rather than calling it value expression, just to yeah, it's value expression, it implements the tokens. It's good to go. Yep. So when we go back here, what we want to pass is actually the type, and do we need to take it? So we can pretty much take this out. So assertion, I believe this returns that with the equal already. Do that session equal then to value pretty much takes yep, we can significantly simplify these. We don't need all this unnecessary handling. We can remove that. We don't even need to do a bunch of this stuff. Don't need these. In fact, that removes the necessity for a bunch of this stuff. It does. We don't have to, but we're gonna take it bit by bit. So go, yeah.
here. We dramatically simplify things. Wow, this was so unnecessary. Um, and we don't even need this. If until what's that? Define is empty. Okay, so when you have define, specify, you shouldn't specify others, which makes sense. Makes sense. But yeah, we're doing table names so that just in case you make a mistake there, because we're able to get the table name and also the result field type. I mean, it's nice to have all this extra stuff, but type result. So it's just clean all this from the beginning. I could have a runtime check there.
If you're trying to make a definition that doesn't belong to the table, so when you're running the migration, that's something we can catch. Yeah, we can catch that. One of your definitions is invalid because you're trying to define this on the wrong table. I think that should be left to the migration. But yeah, I mean this definition is only necessary when you're doing migration anyway. So we might as well delegate that to the migration, I think, because it wouldn't even be a good experience for you to define something against the table and it's overriding what you're doing. So rather, you should throw an error and even able to catch that at compile time because it's defined externally. Um, we would have to yeah. got this. Yes, pretty much just
Mm. Okay, so I think with field receiver we can definitely have infer type or get type. So um, the if Okay, something along this line anyway. So we're gonna get like the value static assertion, and we're gonna get a DB type also. So we can have like just get DB type, and we can also have like get DB type assertion. Yeah, because even if you think about it, basically, let's see if you receive like that type. But we wanna get type because this would give us a type. It's gonna try to infer, right? Gonna try to infer. If we can't infer, if it fall back to user defined type. If user doesn't do that, it's gonna throw an error. So this should actually return a result. You can do DB type. DB type, yep. We take the field name. I need to look at what we're doing with the field name. But I think to do continue tomorrow or at night. I think it's time to or at night. We'll be streaming for 4 hours. Today we've probably streamed 8 hours or so. So I think this is a good place to take a break. These can just be item asserts. So implement the tokens, and I'm thinking we could no. If let's we should just try to do this one is gonna be yep. Value type. I'm pretty happy with this refactoring. It's so much simpler. Few type results, but this isn't even used anywhere anymore. So I guess for that, yeah, this is so much simpler now because pretty much we can just do like actual, as a matter of fact, there's no need to put this in here. You can pretty much just have this. Okay, we already did, and just db type. I may even be able to just abstract that. Yeah, I appreciate you guys for joining. You guys are the MVP. It means a lot to me that you guys join my stream. And
I hope everyone is doing amazingly well. I'm fine and chilling, chilling like chinchilla. Um, yeah. It means a lot to me that you guys join my stream, and we're just getting started. We've made significant progress with the generic support today, and in the course of doing that, we actually support a lot more stuff. Now we simplified a lot of our implementations. First, we modularized the model derived side of the code base. We've done that already for other part of the code base, but we've done that more now for the of derived trait, and I'm really pleased with that. Now we have support for generics, lifetime generics, and all that. And a lot of what we're doing is um, thinking about the context in which the types are being used. Sometimes you need the generics with their trait bound and lifetime bounds. Sometimes you don't need them. Sometimes you want to diff, and more importantly, when we're going through the fields, we want to make sure that we are also gathering all the lifetime and generics bound from the current struct. So let's say you have like a user struct, you can have multiple lifetimes and multiple types defined on it with their respective lifetime bound and type bound. We want to make sure that when we're gathering the metadata from the field, we are also gathering the bounds, the lifetime bounds, and the trait bounds. The reason we want to do that is because you cannot specify a bound within the field type. So we want to gather that, and when we're dealing with direct links, we don't want to use the field type itself, the main raw field type. The reason we don't want to do that is because we usually wrap that around helper struct, helper type that I've created that helps you, that it's like a builder that gives you a lot of benefits out of the box. So for example, if you're linking to a foreign table or node, right? You can get the keys, you can get the values, you can filter the keys, you can filter the values, you can filter out the non-values, and just do all those nice stuff by just using the method. And the nice thing about this is that it's automatically taken care of for you when you're using, for example, select statement. And I've also created a lot of helper method that I call, there's a concept that I've called loaders. So when you say load all links or load link ones or load link menus, right? Let's say you're saying load link menus, it means that when you select the statement, all the fields are linked to um, other foreign tables, like one-to-many relationship. It's going to actually load the value, not just the key. It's not going to give you just the IDs, but it's going to give you the full value, which is cool. Um, and you automatically get that. So if some of the values are none, right, you can use on this method, you can just say value non-null. So it's gonna give you filter out the non-values. By default, the non-values are included. And if you don't load the link, you're gonna get a key. So the keys are gonna be the IDs basically, and the same applies. You're gonna have the non-null values, and you're also gonna have the null values. So because of that, I digressed a little bit. I apologize for that. Because of this situation, we don't actually want to use the main raw field type when we're parsing the struct, right? Rather, we wanna we wanna use the attribute link many, where the user is gonna specify the foreign struct itself. This place, we the user cannot use the helper wrapper, the the type wrapper or struct wrapper. The user is just going to specify the type, which is going to have the lifetime and the generics itself. And the reason we do this is because think about a situation. Even though, let's say the user uses the link many helper struct, which wraps the struct itself. So let's say link many into um, open and close, what's it called, arrow, right? Whatever it's called, right? And you put in the user. Yeah, realistically, technically, we can actually parse the user out. We just need to go through the path, right? Go to the last segment of it and get the angle bracket, and just basically get everything within that segment. We can get all the types, right? But the problem with this, the challenge with this or limitation is that we cannot really do this when the user um, we cannot use this if the user uses a type alias there, right? And because of this situation, we're enforcing that the user actually specifies the attribute where you're not using the wrapper type, you're just specifying this foreign struct itself. Granted, we can probably get a way around it. Maybe on the type, we implement a method that generates some tokens as an associated function on the struct, and we basically propagate that to the builder helper struct. But then you see this has a layer of indirection, and this is not ideal for us. So anyways, um if you watched this stream as a whole, you're gonna realize that actually when you start getting into the relationship between the local and the foreign node via the edge, the connection, it gets a little bit more complicated, because now you're not only dealing with a direct link to the destination node, but you're also dealing with the edge, and the edge itself is a struct, because the edge itself is a model, right? That stores information about the origin and destination node. Martin, oh, what's up? It's good to have you here. What's good? What? Oh, I finally was able to join. Yeah, I was actually just thinking of wrapping up and maybe get some sleep. I know I could probably still go for like 10 hours more, but I'm trying to, have a little bit of rest in my life also. But you're welcome. How's it going? It's good to have you back, and I appreciate you for joining. I appreciate you for always supporting the channel, the brand, the stream. You're amazing. How's it going today? What are you up to? What have you been up to? Yeah, and guys, I know my stream or streaming or streams are chaotic. I hope it's gonna get better. I'm a chaotic person myself to some extent. But the whole point is that I'm just trying to focus on the project, because I've been working on this project, like I said, for about 14 months, and I just started like about 4 months ago. I was like, why don't I just share my screen, right? Instead of working in stealth mode, and I started sharing my screen, and I'm actually excited. I'm glad that I did that, because um, but unfortunately, the downside of that is I've not been able to focus on making the stream better. I've got proper camera. I've got a Sony A7S III. I've had the camera for about 2 years now. I've got a Rode mic, everything, but I never use them. I just use pretty much my laptop webcam and my laptop mic. But I am trying to avoid getting distracted pending the time that this project gets done. I really want to finish this project so you guys can benefit from it. And also, trust,
I am trying to add support to Trust update to Tailwind v4 and also Daisy UI v4, and also supporting array of class names. If you've used like class names in TypeScript, I'm trying to support something like that, so you don't have to write a gigantic if-else statement. You can just basically use some nice syntax. Um, and I'm also creating a standalone CSS library that is not tied to Tailwind. You can use it for any other CSS framework. Um, but I think these two should probably take a couple of days. Then from this project itself, I will probably have like two open source projects from it, like static assertion. I have some static assertion functions or helpers I've created. I'm looking to open source that and add more to that. You know, if you use TypeScript, there are things like omit, pick, and exclude and stuff like that. I'm looking to bring them to Rust, and actually the implementation came to my mind while I was asleep last year. So I tend to solve a lot of problem when I'm sleeping. I see, ha ha ha, doing good, doing good. Still studying, going to start a SPA few days from now. Do you mean like spa? Are you going to, what kind of spa are you going to? Are you going to a Thai a Thai spa, or and then I'm just kidding. Single page application. Start building. Yeah, that's great. I'm really excited to hear what you're working on. It's wonderful. So guys, we have come very far, and like I actually saw someone already using Surreal-orm, like pointing directly to master, even though I've not published on Crate.io. So that's great, wonderful that even though we're not even done with alpha, people are already benefited from it. I like I said, I also have an animation and gesture library planned. I have a CDK library planned for like um, working with Kubernetes. Like you think about code, infrastructure as code. I'm working on that, something like CDK, ATES, Pulumi and stuff, but in Rust, which will support customize your standard Kubernetes manifest and Helm charts, and then we start supporting the vendors. I'm excited. Like I've always said, my goal is to die empty, and by that I mean I think I've learned a lot of things over the course of my life, and I would like to also share all those knowledge that I've gained over the years, and also maybe donate all the money I have at some point. That's what I mean by die with nothing. And also build as much as possible stuff that can benefit every human by the time I'm dead. I want to make sure that if I'm told that I've got cancer today and I've got like a few days or a few months more, I feel a minimized sense of regret, or and what that would mean for me is not having lived a life worthwhile. And a life worthwhile for me is knowing that everything I benefited, gained, including my knowledge, wealth of knowledge and asset, which I'm going nowhere with. I didn't get to like share that while I was alive, but I know that now one consolation, not consolation, actually one kind of peace of mind I get from working on this project. One excitement, peace of mind, and solace. Solace is the right word. One solace I get um, working on all these projects is that I am already feeling like I'm getting closer to minimizing the sense of regrets, because I know if I die today, people are gonna be benefiting from SurrealORM and Trust. Maybe for the next year, decade, century, who knows? Maybe it's gonna be a foundation for the next stuff. Maybe a lot of people are gonna learn a lot of stuff from it,
and take that lesson and build something better. Or maybe this would be a foundation tool for some other stuff. Maybe people will learn from a mistake and learn not to do it this way. Either ways, it's gonna be a win-win for everyone. So I'm excited. Single page application. No, I know. I was just kidding. That's very cool. Are there any reviews from the pre-alpha users? I've actually not really shared anything, but someone is using SurrealORM already, and that's quite interesting because I haven't actually published. So previously I was looking to support generics in subsequent release, but I just decided to bite the bullet. So Zayadeb says I'm adding it directly from GitHub since the remote create is not really working. I've not published it, that's why it's not working. I think the builder semantic idioms behind link many and link one saved me a bunch of time writing it myself. Great work. So guys, we're doing great. I actually need to respond to that. Yeah, this is the last main stuff for um alpha release. I think it's nice to just have it now. And also, I am doing a lot of refactoring now so that the code base will be more approachable as more people start like contributing. In one of the previous streams we had, someone was actually asking how to contribute. But I want to make sure that I have things in order as much as possible so that it's easier for other people to contribute, and also add as much unit and integration tests. And like I mentioned, we actually have over 2,000 tests, um, and probably more than 4,000 assertions. So I am pretty confident that this is the most tested database tooling code base in Rust right now. So guys, we're doing great, and we have much more coming. That's amazing. First user. That is true. That's the first user review. Zaya Dev. So thanks. I appreciate it. So guys, I appreciate your suggestions. Let me know what you want to see and what you would like to see from me, hear from me, and just feedback. All feedback are like welcome, constructive, and even destructive. Destructive feedback make us stronger. I'm just kidding, guys. Take it easy. But I appreciate you guys. It's always nice to just do this, and I hope you guys find my contribution to this world, no matter how little, useful. And let me know what else you want me to build. I'm mostly working on TypeScript now. I mean Rust, but I have a lot of ideas on things to build for TypeScript. And actually, Surreal-orm is like, you can think about it as like a protocol that could be applied, implemented in other languages that support that kind of semantic. You're using like, we have the primitive to already support a lot of things in like TypeScript. You have decorators. You can do some reflection stuff there, metadata. So, and you can use the interface system in TypeScript. Um, so you can do a lot of things, and of course you have the power of TypeScript also. So you can write some nice parser, and for languages that can support it, they can still get a lot of benefits. You can still support quite a lot. But of course, if you're using like a language like Python, you wouldn't be able to support compile time checks. However, we could indirectly. So what I could do in the case of a language like that, I could write a parser in Rust. So I could implement something for the LSP that does the check. You can think of it like what do we call this?
ESLint, TSLint, and all that. Basically, like a linter, we can implement a linter and also you can hook the linter to the language server protocol so that you get at compile time check at you get compile time check with the LSP, and also you can run a linter against your Python code base that checks all the queries and sees if something is wrong, and we can implement that in Rust, which is going to make it fast. So there's a lot of possibilities. I'm just so excited. So let let me know how I'm doing. Something I could do better. But anyway, guys, it's time to go get some rest. It's already past midnight now, and I need to crash. I appreciate you, Martin. Thanks. I appreciate you for joining. Paul Millsap, it means a lot. Thanks for joining. Old Lazy Lobster, thanks for joining. Brett Hagen, it means a lot that you joined today, and hope to welcome you back. Anurag Mishra, thanks for subscribing. Thanks for joining. Um, Martin said, keep going, Oye. I'll be supporting you always. I'm sure that a lot will benefit from your efforts, one thing at a time, with the project of yours. So many, haha. Good night, Oye. See you soon. Thanks so much, Martin. You're amazing. You're amazing. I appreciate that a lot. That means a lot. That's gonna make me sleep well tonight. Thank you. Thank you. Thank you. You guys have been really, really amazing and very supportive, and it means a lot to me. I don't take that for granted because, you know, um, my work means nothing without you guys. Without you guys using my work, like it's basically useless, right? Even if I'm using it, like it's nice when a lot more people can use it. And I also appreciate all the feedback you guys give and all the encouraging words. It means a lot to me. Thank you guys, and I'll see you guys soon.